Here are solutions to homework set number 4 for 476-676 Advanced Embedded Systems. This homework set looks at timing and analog I/O. So the first problem is using a DC motor that has an analog output. I want to be able to control the speed from minus 100% to plus 100% using a potentiometer on your board. So this is what I'm shooting for. I want to be able to make the motor spin forward in varying speed with the analog input. I want to be able to slow it down, make it go backwards. Basically control the speed using analog input. So how do I do that? Well, the first one is connect up your motor to make sure it can spin. So here I'm going to connect it up as from the Pico board. I've got power and ground going to my H bridge. I've got these two wires, output GP0, GP1, going to my two inputs, and the motor output goes to the motor. In terms of software, I'm going to set it up so that I can make it go forward for 2 seconds, stop for 2 seconds, backwards for 2 seconds. There's connections. So let's try that. Over in Thani, problem number 1, I'll make the output pins output go forward for 2 seconds, stop, reverse 2 seconds. So let's do that again. I'll expand this, go forward for 2 seconds, stop, reverse 2 seconds, stop. Okay, I'm fairly convinced the hardware is correct. I can make the motor spin. Once that works, let's read the analog input. This is the A to D converter on the Pico. I'll import ADC to read it. I'll do AD, make that analog input, read it. That gives you a number between 0 and 65,000. This converts it to voltage. I'll read the center position. So right now in the center, that's my home position. Everything's relative to center position. Convert to voltage. And what I'll do is just do numerical integration. Integrate the voltage. If the voltage is positive, integrate up. Otherwise, integrate down. In terms of software, here's what she does in software. They call it analog out. What that does is that it outputs a PWM signal. If I have positive PWM, output that on the first pin. If it's negative, output it on the lower pin. So that's forward and reverse. So what that looks like when I run it, you can see down here, this is the voltage that I'm reading in relative to center. 1.8 volts relative to center, minus 1.4 volts relative to center. The second column is the percent. So here's now 78, 90, 100% speed. Dropping the percentage. That's my integration. I now have a negative voltage, negative percentage. That goes backwards. So with the analog inputs, analog outputs, I can read the potentiometer, and I can output an analog voltage to drive a DC motor. With the Pi Picos, typically the voltages are output using PWM. I chose 1 kilohertz. Not sure why I chose a kilohertz, but it's just a number. Kilohertz means there's 1 kilohertz winding going on. If I change the frequency to something like a... So this one is a little bit different. If I move the potentiometer, I'm going to see the percentage going 0 to 100%. What I'm doing is I'm changing the pulse width. When I get down to 0.5 milliseconds, that's all the way in one direction. This is pulse width all the way the other direction. To 100%, that's 2.5 millisecond pulse width. The pulse width controls the angle. In your lab kit, you've got one of these small motors, kind of same idea. This is a $50 version. You can see the integration, well, a slight DC offset is integrating. That's another way to control motors with the pulse width, again related to the timing functions in Python. So it's basically homework set number 4, using the timing library, analog inputs and outputs, and with that I can control 2 different types of DC motors. Ones that have a pulse width as an input, ones that have an analog input. We'll talk more about these motors in a later lecture, but that kind of gives you an idea of some of the timing functions in Python. Homework set number 4 for 476. Let's make this bigger so you can see it. Kind of a side issue, if you want to play with these motors, we've got 4 of them in stock. They're available to play with.